All right, so continuing our discussion on working with sets, so we will still be talking about subsets, and this time also we have to find a complement of a set. Okay, so a few more things that we need to remember. So when we say a subset, all right, it's a smaller set that is found in a bigger set, which means any element from the bigger set, any element from the smaller set will always be found in the bigger set, okay? So that's why it's called a subset. It's a smaller group of elements coming from the bigger set. And then of course we have our empty set. From the name itself, empty. It doesn't have any elements in it. Now you have to remember that the empty set is always a subset of any kind of set. All right? So I'm gonna have some examples here next, and let's find the subsets of the following sets, okay? So we have a set that contains the elements 3, 4, and 5. So as you can see, we have 3 elements in it. So to identify the different subsets, we start putting in elements one at a time, increasing the number of elements for each smaller group. So we start with the empty set, okay? We start with nothing. So the empty set will always be a subset. All you need to do is just put the braces, okay? Now we put the sets that contain only one element. So that would be the set of 3, the set containing 4, the set containing 5. Okay, so how many subsets are these now? There's 4 of them. Now, we cannot just simply let just one element in it. We can also have subsets that has 2 elements in them. So it will be the set that contains 3 and 4. Okay, you have 3 and 5. All right. We also have 4 and 5, the set that contains 4 and 5. All right. And then, so we have no element, 1 element, 2 element sets. Then the last one would be the 3 element set, and that is the set that is given to us. So that is 3, 4, 5. So in this case, how many subsets did we have? We have 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets all in all. All right. So why don't you try the next example? Go ahead, list down all the subsets of set S that contains A, B, and C. So if you will follow our example above here, you will see that we will have the same number of subsets. There will also be 8 in there, empty set, 1 element, 2 elements, 3 elements, okay? So the more elements that you have on in your main set, then you will have more subsets because you will be increasing the number of elements for each subset. Okay. So some more things. Okay, we also have what we call as the universal set. You will always hear the term universal set because it's the largest set that we are talking about. So if we say the universal set is the whole our real number, so that's the biggest set that we have. If we say we're talking about the subset of integers, so integers is a smaller group, a smaller set that is found in the universal set, which is the real numbers. Okay, now why is having a universal set important, or why is defining a universal set important? When we talk about the complement of a set, we are talking about the set of all elements in the universal, in the bigger group, that are not in a given set. Okay, so complements of a set, if we're going to visualize it, okay, so let's say that let's say that this is our universal set, okay? The rectangle is our universal set, and anything inside the circle is your set A, all right? So when we talk about complement of set A, any element that is not inside this circle. And so if we're going to take a look at it, it's going to be the part of the rectangle that is not inside the circle, and we use apostrophe to represent the complement. Okay, so just remember, complement is anything that is in the universal set that is not in a given set. Let's have some examples to make sure it's clear. All right, So imagine that we have our universal set. It's the king, queen, bishop, knight, rook, and pawn. And set A is the set of chess pieces that move side to side. And so, what is the complement of set A? Now, for you who are not familiar with chess, all right, so for those of you who are not familiar with chess, well, you gotta Google a little bit about this. So if we're going to define the set A is composed of the pieces that can move sideways, okay, side to side. So definitely the king can move to the side. All right, so that would be one move, either forward, sidewards, or diagonal. So the king is included here. Okay, another that can move side to side is the rook. Okay, it can go horizontal, it can go straight like that. So that's going to be the rook. The pawn can move forward again. So you cannot have that side to side. The queen, definitely. The queen is the ultimate. It can move in any direction. All right. Now the knight can move diagonal. The bishop can move diagonally. The knight can only make like L shapes. All right. So these are your set A. So when we talk about the complement, so what is the complement of set A? Everything that is in the universal set that is not in this group. So the king is there, the queen is there, bishop, as you can see, is not in set A. So bishop is in the complement. The knight is also not in set A, so it belongs to the it belongs to the complement. The rook, as you can see, is in set A, and then the pawn is going to be in the complement. So that is how you can identify the complement of any given set. All right. So why don't you try this next example on your own? Go ahead, find the complement of set A. Okay, so if you know your months of the year, okay, the months with 31 days are here, set A, and then the complement are those with that doesn't have 31 days in them. Okay. So to summarize our discussion, sets are a basic of mathematical language. You can write sets in different ways. You can also form smaller sets of elements from a larger set. And also you can describe elements that are not in a given set.